So we'll put you in groups of 3 tomorrow, and then basically I'll hop around to different ones, or if you have a question, you can invite me into your group or whatnot. So that's good. The answers to page 9 and 10 can be found here. Those are problems like the ones that you finished up on page 7 and 8. They're just a little bit different looking. When you look at them here, page 2 is a different format. So basically, it's the same problems. If you take a look, it says, if 0.034 moles of iron 3 chloride is dissolved in enough water. I've just changed the format so that they're not side by side. They are the same problems though. So just keep that in mind. If you're like, look at it real quick, you might be like, what's this? They are the same problems. So don't overpass it just because they don't look the same. And then today we want to discuss percent mass, molality, density, and mole fraction, and how they work together through a few practice problems. Because those of you coming in on Thursday and Friday, we have another lab for you guys. I know period 9, it's the only that at the end of the week that we can do this lab. But notice that this lab does not have a procedure. So we are going to have to make the procedure for that. And you are going to find the percent by mass, the molality, and the molarity, those 3 things. I will then give you the molarity that I made the solution at so that you can calculate the percent error and then come up with explanations as to why. The key thing here is I'm going to give you basically just a sodium chloride salt solution. From that point on, you're going to measure out how much of that you want to use or whatever, and then figure out the rest of the stuff. So maybe if you have questions today, that can help you out with your procedure for Friday. Wonderful. What else?
Mr. Jackson, I have a quick question.
Yeah.
So for that group quiz, so are we just like, is it just basically a quiz, but you're just working with other people?
Yes.
And then do we also, like the individual quiz, do we do like after school or whenever we have time as well?
Yeah, so the group quiz, probably since there's at least 3 of you working together, I think that shouldn't take very long. And then the individual molarity quiz is less problems. It shouldn't take you long.
All right, thank you.
Most of the time we do this in one classroom. Period. Yep. Cool. And then Thursday, we are going over more of these calculation problems and then discussing the laboratory. That's the day I'm worried most about because maybe we've done it before. I guess it's not that big of a deal, but basically put you guys into your groups and then you can discuss how you're going to find these things in the laboratory. This section seems to be difficult, and I don't know why. If it's like just, do you really understand what a solution is? Like those particles are in there, you know. If that like evaporates, then you're going to be left with the solute on the bottom of the cup, right? These type of things. The problem that I foresee it having is that maybe you guys don't have the laboratory experience that I'm used to students having by this point, just because of, you know, how the year has been. But like starting with clean glassware, you know, stuff like that, starting with dry glassware for different things. That can be a big deal. All right. Oh yeah, I forgot. Hopefully you get the solubility curve questions that completed. I think we started that like last Tuesday and it was due on Sunday. So had quite a time to do that. So please make sure that if you didn't get those done, that you do grab those and put those into the drop-off box. Remember, it's got the table on it.
Mr. Jackson?
Yes.
If for the quiz, 2 quizzes tomorrow, there's not going to be any like molality or density questions, right? It's just going to be over molarity.
Just molarity and the dilution problems. Yep. Just like these on here. So if we take a look here, you were to do, I believe, 8, 9, and 10. Take a look at those answers and make sure that you got them. I got 35 milliliters, 0.10 moles per liter, and 0.180 moles per liter. Some weird kids acting out in the hall. I don't know what's going on out there. To go out there and discipline somebody. Put my discipline voice on. So again, there are more practice problems for this. The answers are on today's calendar. Where I want you to get is I want you to get to this right here. The next note page on the 11th. You'll need your periodic table for this. So this has a bunch of different types of concentrations. Before the end of this unit, I think you'll realize why molarity is a chemist's favorite. But density is the mass per liter or mass per unit volume. Molality. Now look at molality and look at molarity. Molarity includes the solution. Molality does not include the solution. It's moles of solute per kilograms of solvent. So these two things are separate. The solute is dissolved in the solvent, but you've got two totally different types of things here. For these two, it's mass of solution, liters of solution. Moles of solute, liters of solution. Right? Keep in mind that density is the entire solution both times. It's the mass of the whole solution, including the solute and the solvent, per liter of solute and solvent. Right? So it's a little bit different. A percent by mass is the mass of the part divided by mass of the whole. So when we say mass of the solute, the mass of the solution is both the mass of the solute and the mass of the solvent. And down here, mole fraction is the moles of the solute, or in reality, it's the moles of the part divided by the moles of the whole. So a lot of times you'll find the mole fraction for the solute, the moles of solute over moles of solute plus moles of solvent. But you could be doing the moles of solution or solvent, over moles of total. You can find the mole fraction for that. So those are the different types of concentration. Chemists a lot of times use molarity, but sometimes if we are trying to find, for example, the change in boiling point of a solution versus a solvent, 100% solvent, we need molality. It won't work without molality. Sometimes if we're trying to find, for example, the new vapor pressure, we need the mole fraction of the solvent. If we're trying to find these extra things, we need some extra little pieces. A mole fraction is actually shown by doing like X and then the formula. All right. So problem number 1, what is the molarity of a solution made by dissolving 0.798 grams of potassium permanganate in enough water to make 50 milliliters of solution? So we have to ask ourselves what we're looking for. And what are we looking for?
Molarity.
Or molarity. So that means we want moles per liter. Cool. I'll try to close a few things on here. Maybe it'll speed this thing up. Come on, man. So slow. Looking for molarity, moles per liter. Which of these things can get us moles?
The grams of KMnO4.
Yep, grams. 0.798 grams of KMnO4. And we do have 2 units, so we're gonna need this over something. 50 milliliters can get us liters. Every 1,000 milliliters is 1 liter. 4 times 16 plus 39.10 plus 54.94. So 158.04 from the periodic table. Grams is 1 mole. .798 divided by 50 times 1,000 divided by 158.04.
It's about 0.336.
That's not right. She did 15. 0.798 divided by 50 times 1,000 divided by 158.04.
The answer is about 0.1009.
So that's going to round up to 0.101 moles per liter. That should not have been trouble for us because that is the same thing we've been doing for quite some time. For at least a few days. I'm not liking this pen too much, so I'm going to switch out. This feels like it's like fine point pen. I'm more of a medium point guy. It's like 0.05 or something. So questions on that? So last period, somebody let me go almost 20 minutes, and then they asked me where I'm getting some of these numbers. They didn't know where I was getting the 158.04. That's the molar mass. You have to have your periodic table next to you in order to get that. So I mean, please, if you have a question, don't wait around on it because, you know, the questions probably have pretty easy answers. Just please don't wait around on it. Make sure that you ask it whenever you know it. Again, I don't suggest that you use the, what is it, the chat bar, because I don't see that very often. If you do use the chat bar, make sure that you include everybody and not just private message me. That way they can tell me, hey, you've got a message. All right, are we ready for the tough stuff? A solution was prepared by combining 7.50 grams of sodium chloride with 150 milliliters of water. The final volume of the solution was 151 milliliters. From this information, calculate the following: mass percent, molarity, molality, and mole fraction.
Should we assume that the density of water is 1 gram per milliliter?
Yep.
Okay.
So what we've got going on here is we've got 150 milliliters of water, right? We're adding 7.50 grams of salt to it. That increases the volume by what looks to be 1 milliliter. And that's it. So we know we have put 7.50 grams in there of NaCl. We know that there are 150 milliliters of water. And we know that the volume now of the solution equals 151 milliliters. That's all the information that we can get from that. Who is the brave soul that wants to figure out one of these things?
Yeah, I can.
All right, which one are you going to choose?
I can do mass percent.
All right. So mass percent, that's why you asked me about the density of water, right? We know the density of water is 1 gram per milliliter.
Yeah.
So what is the mass of the solute?
150.0 grams.
Solute.
Oh, 7.50 grams, sorry.
All right. So the mass percent is the mass of the solute over the mass of the solution. So we're going to put 7.50 grams on top. And what is it going to be on bottom? What is the mass of the solution?
The mass of the solution is 151 milliliters.
Nope. That's not a mass.
Oh, sorry. The mass of the solution is 150 grams, right?
Nope. Somebody want to help?
No,
me out?
it's 150 plus the 7.50 grams.
There you go. So it's 150.0 grams plus 7.50 grams. Explain why it's both.
Because you have to take the mass of the solvent and the mass of the solute to get the total mass of the solution.
There we go, right? Make sense? So with that, we then need to make sure that we multiply that by 100. 7.50 divided by 157.50 times 100.
It's about 4.7619.
Always got two decimal places with percent for this class. And we get 4.76. So actually I did the easy one. Who's ready for the hard one now? Anybody do one of them? I'll give you a hint. The molality and molarity are pretty easy. We know molarity, we've seen it, so you could do that one pretty easily. But molality is also pretty easy if you think about it.
I can do the molarity.
Okay. So how are you going to get moles of solute?
Or when you just start with the 7.5 grams
Good. So we have 7.5 grams of NaCl.
and then put that over, would it be the 151 milliliters?
It would. Very good. 151 milliliters, because that is the volume of the solution. So then we need to change 151 milliliters to a liter. 22.99 plus 35.45.
The answer is 58.44.
And the molarity of sodium chloride, I'm sorry, the molar mass of sodium chloride is 58.44 grams per mole. So there we go. 7.50 divided by 151 times 1,000 divided by 58.44.
It's about 0.8499.
8499 is going to become 850. All right, we're running out of things now. What's the next one we want to do? Nick, can you do molality? No? Gabe, how about you? Molality?
Probably not.
Probably not. Well, what do you need for molality? You need moles and you need kilograms. So can you find the moles of the solute?
I mean, eventually.
Eventually. You just saw, who was that? Brody do it?
I mean, you just have to like divide it by the molar mass.
All right, so we're gonna start with the 7.50 grams of NaCl. And every 58.44 grams is 1 mole. Cool. We just need to find out kilograms of solvent. So how much solvent do we have?
$7.50 grams.
That's solute.
My bad.
How much solvent do we have?
150 milliliters.
150 milliliters of water, which means that since water's density is 1 gram per milliliter, how many grams do we have?
150.
Right? And then every 1,000 grams is 1 kilogram. $7.50 divided by 150 divided by 58.44 times 1,000. Hmm. 7.50 divided by 150 divided by 58.44 times 1,000. Not playing today.
The answer is 3.8275.
I don't believe it on that. So we got 7.5 divided by 150 divided by 58.44 times 1,000. We get 0.085557, which will round to 0.856.
Do we express molality as like a lowercase m?
Yep, you could also do that with 0.0856 lowercase m. Questions there? All right, who can find me the moles of the solute? You can find the moles of the solute, you can start to do the mole fraction.
I think I know how to do it.
All right,
So can you start with start with 7.50 grams and then convert that into moles?
7.5 divided by 58.44.
It's about 0.1283.
And then you put that over 7.50 plus 150.0.
Close. We've got to change those to moles too. Right? So we got to change the,
Oh, yeah.
it's okay. 150 is 18.02 grams per 1 mole. 150 divided by 18.02.
That would be about 8.324.
0.12834 plus 8.3241.
The answer is about 8.4524.
0.12834 divided by 8.4524.
It's about 0.01518.
So that gives us 0.0152. Notice that a mole fraction does not have any units because the moles cancel out. So it's just a ratio. For every 1 mole of solution, 0.0152 moles of water. I'm sorry, of sodium chloride. So it's just a ratio. All right.
Mr. Jackson,
Yeah.
what was the last step? I'm sorry. What was the last step that you did to get the 0.0152?
So I took basically Emma got us the top and then she got us this part and then the bottom. We had to add these two together, which is right here. Add those two together to get this right here. And then we take the top and divide it by the bottom to get the 0.0152. So remember, if you take a look up here, it's moles of solute divided by moles of solute plus moles of solvent. That's exactly what we did. And that's exactly what we're going to do again right here. So a bleaching solution contains sodium hypochlorite. dissolved in water. The solution is 0.750 molar or molal, I'm sorry. Calculate the mole fraction. So we want the mole fraction. I already have one part of this mole fraction. What part do I have?
The solution.
I don't know what you mean there.
Don't you have the amount of grams of the solute?
Nope, I don't. What is this? Molal.
Do you have the moles of the solute?
Who is that?
Brody.
Molality.
I have the moles of the solute. So I can go ahead and put that up there and then this down here as well. Now I just got to find the moles of the solvent. Because this is 0.750 moles per what?
1,000 grams of like a solvent.
Yeah, it's per kilogram of solvent, which in your head you've already converted to 1,000 grams. So how can we get, what is the solvent?
Water.
Water. So if we know we have 1,000 grams of water, can we get the moles of water?
A divided by the molar mass.
What's the molar mass of water?
18.02.
There we go. 1,000 divided by 18.02. You're not playing again.
That would be about 55.4938.
55.494.
How did you know there were 1,000 grams of water?
By definition, the molality is moles per kilogram solvent. Just like if we were given the molarity is 5.5 molar, that means we have 5.5 moles for every 1 liter of solvent, right? So it's the same thing. If it were 5.5 molal, we would have 5.5 moles for every 1 kilogram of solvent. $55.494 plus 0.75.
That would be 56.244.
0.750 divided by 56.244.
It's about 0.01.
0.750 divided by 56.244.
The answer is about 0.01333.
Again, the units cancel out, leaving us with 0.0133 mole to mole ratio. What do you think? Hardest thing we've done this semester? Probably a lot more thinking than we're used to, right? I don't know. So if we take a look here, number 4. A solution is 0.585 molal H2C2O4. The density of the solution is 1.002 grams per milliliter. Calculate the molarity. What do we need for moles?
Well, don't you already have the moles of like the solute since
Already
they
got the
gave
moles.
molality?
0.585 moles. Cool. So now I just got to find the liters of solution. How are we going to do this? Somebody's chatting on me.
Use the density formula.
We're going to use the density. Leo, that's funny. The answers have always been on there on most of these assignments, right? So we want to use the density. The problem is this is the density of the solution. So how much water do I have?
1,000 grams or 1 kilogram.
1,000 grams of water. That's just the mass of the solvent. That's not the mass of the solution. How can I find the mass of the solution?
Can't you take the moles of the solute times the molar mass and add it back to the grams of the solvent?
Got it. So I need to find the grams of the solute. (2.02) plus 24.02 plus 4 times 16.
That would be 90.04.
90.04 times 0.585.
It's 52.6734.
We're going to add these together. So we get 1,052.67 grams. That's of the solution. So now what can I do with that density, Emma? What's going on bottom? What has
Grams.
grams? Good. And every 1.022 gram is 1 milliliter. 1052.67 divided by 1.022. I don't know what her problem is today. 1052.67 divided by 1.022. We get 1030.01, but the 1030 is going to be our significant digit, I believe. That is milliliters. So if I want to find molarity, I've got to change that to liters. .585 divided by 1030 times 1,000. We get 0.5679, which rounds to 0.568. What do we think? What's the hard part? It being the first time that we've seen these equations. How's our prior knowledge? Do we get density in moles? Are we okay with all of that? Right? These are questions that you need to ask yourself on this. I don't know. This might be the hardest thing that we've done this semester. It does require both math skills and thinking. I mean, it's not as fun as dimensional analysis, that's for sure. But hopefully you can see how all of these things are connected. Hopefully before Friday. I'll start the next one for you, and then I'll let you guys go off on your own for it. The reason why I want to start it is because it does give us the first time that we are given percent by mass. So let's try that. Can anybody tell me what this 95% by mass means? That means we have how many grams of what?
You have 95 grams of spheric acid and 100 grams of solution.
Yep, so if I have 95 grams of sulfuric acid and a 100 grams of solution, how many grams of water do I have?
5.
5 grams of water. And again, significant digit on these would go out 2 decimal places, because it is coming from the percent. So now we have the mass of the H2SO4, we have the mass of the water. You think you can get the rest of the 3? What is the solvent here?
Water.
Water is still the solvent. I'm sure you can change 95 grams of H2SO4 to moles. So that should be easy for you to get the molality. I'm sure you can change 5 grams of H2O into moles. That should be able to get you the mole fraction. What's the hardest one going to be to get here?
Maybe the molarity.
Yeah, because remember, molarity is moles per liter of solution. So what does that mean we have to do to get the volume here of the solution?
Use the density.
Yeah. So we know we have 100 grams of substance, right? And every 1.84 grams is 1 milliliter. 100 divided by 1.84.
The answer is about 54.3478.
So that's 54.35 milliliters. So right there is our volume. We'd have to change that to liters to get molarity, but I think with all 3 of these things, that should be pretty easy for you guys. If I remember correctly, the first 5 are the hardest. I could be wrong. But as Leo said, the answers are here to check. And I don't believe any of these answers are wrong. So I know some of you guys, like, sometimes the answer will be wrong or something like that. And you'll be like, I think I did it right, but I don't know. I don't think any of these answers are wrong. If I remember correctly, I think I fixed them all.
Mr. Jackson,
Yeah.
when you found those milliliters, why do you multiply by 100?
This 100,
Yeah,
because that's the mass of this solution.
but like isn't like the 1.4 isn't that the density of the acid? So when you do 95 grams,
Whenever we say acid, we actually mean that the solution. The
oh, okay.
Yeah. And somebody asked me last period, it's like, well, how do you know you don't have 200 of it? Well, if I had 200, then what 190 would be acid and 10 would be H2O. Mathematically, it would still work out. I chose the amount I had to be 100 just so that it would be easier for me. Any questions? Ooh, excuse me. All right then. For tomorrow, prepare for the quiz. For Thursday, make sure you have 5, 6, 7, 8 done on this. That way we can discuss them and discuss the laboratory with those brave individuals that are coming in on Friday. It looks like, well, I mean, I guess it doesn't matter for this class, but it looks like the board is talking tonight about merging Red Day and Black Day students together so that they come all week. I'm not sure if that's going to happen or not, but that's what some people were talking about today. I'm not sure if that would be interesting to you, but I don't think it'll affect you. It may affect Brody. Brody might come back if there's more people than just him and I. Is that what made it awkward, Brody?
No.
But so I don't know. That may change some of your other classes and make you know, I asked my period 1 and they were like, yeah. I don't know. I don't think that if you are you know, worried about you or in your household, then obviously you should stay virtual in my opinion.
So do we have any homework or is it just steady for the 2 quizzes tomorrow?
So I mean, yeah, whenever you ask, do we have any homework? It's one of those things where it's totally up to you.
Yeah.
If you have this stuff down, then there's no need to study for it. If you're having trouble with, maybe today's stuff, but not last week's stuff, then obviously you might want to go and take a look at the answers to pages 9 and 10 here. That could help you out with that. And if you got last week's stuff good, if you're like ready for that quiz, but you're a little bit nervous about this stuff, then make sure you go through 5, 6, 7, 8 for Thursday. I mean, you could do that tonight, and that would actually make you okay for tomorrow's stuff. The only stuff that's not on there is the dilution problem. All right, guys, I'm going to stop the recording.